Hello everyone, welcome back to my channel. ಲಾಸ್ಟ್ ವಿಡಿಯೋದಲ್ಲಿ ಸಾಲಿಬಿಲಿಟಿ ಥಿಯರಿ ಮಾಡಿದ್ದೆ. ಈ ವಿಡಿಯೋದಲ್ಲಿ ಅದ್ರ ಬೇಸ್ಡ್ ಕ್ವಶನ್ಸ್ ಸಾಲ್ವ್ ಮಾಡ್ತಿದ್ದೀನಿ. ಫಸ್ಟ್ ಕ್ವಶನ್ KCET ಅಲ್ಲಿ ಕೇಳಿದ್ರು 2025 ಅಲ್ಲಿ ವೇರಿಯೇಷನ್ ಆಫ್ ಸಾಲಿಬಿಲಿಟಿ ವಿತ್ ಟೆಂಪರೇಚರ್ ಫಾರ್ ಎ ಗ್ಯಾಸ್ ಇನ್ ಲಿಕ್ವಿಡ್ ಇಸ್ ಶೋನ್ ಬೈ ದ ಫಾಲೋಯಿಂಗ್ ಗ್ರಾಫ್ಸ್. ದ correct representation is. So correct representation, what they're asking, variability between solubility and temperature. What is the relationship between solubility and temperature? Solubility and temperature is, solubility is inversely proportional. So inversely proportional means solubility is increasing means temperature will decreases. In first option it is increasing, so it is not the correct option. Here it is constant, this one also not the correct answer. Here first it is increasing, then it is decreasing, this one also wrong. Here what is happening, temperature is less means solubility is more, temperature is increasing means solubility is decreasing. So correct answer is D. Okay, then next question, if N2 gas is bubbled through water at 293 Kelvin, how many moles of nitrogen gas would dissolve in 1 liter of water? Assume that N2 exerts a partial pressure of 0.987 bar and given is KH value they gave. So here what you will do, what they are asking, they are asking number of moles of, how many number of moles of N2, they are asking number of moles of N2. What and all they gave, first that one you see, it is dissolved in 1 liter of water means given mass of water they gave and partial pressure they gave. So here we have to follow which formula, that is Henry's law formula, P is equal to KH into chi. So that one here they gave P and KH value they gave. So we want to calculate mole fraction of N2 gas. So P value substitute ಮಾಡಿ KH value substitute ಮಾಡಿದ್ರೆ we'll get mole fraction of N2. So this we got to know. Then in this mole fraction of N2, number of moles of N2 I have to calculate. So number of moles of water first we'll calculate. Number of moles of water is given mass is 1 liter. 1 liter is equal to 1000 gram divided by molar mass of water is 18. 1000 by 18 is 55.5. Got it. Then next, this is diluted solution because 1 liter is, this is diluted solution. In case of diluted solution, mole fraction of N2 is equal to number of moles of N2 divided by number of moles of water. Here N2 is very small, so we'll neglect this one. We'll get this value we already calculated here, that value we added here. Then N2 value I have to find out. Number of moles of H2 I got to know, that is 55.5. Easily we can find out number of moles of N2. Okay, number of moles of N2 is 7.16 into 10 to the power of -4. Then solubility of gas in liquid increase with, solubility of gas in liquid, how it will increase, the what and all terms they gave pressure and temperature. We know this solubility is directly proportional to temperature, inversely proportional to, sorry, directly proportional to pressure, inversely proportional to temperature. So this one you should remember in case of gas in liquid. Okay, now so directly proportional to pressure means pressure should increase. Here decrease of pressure is there, so wrong. Here also decrease of pressure is there, wrong. Here increase of pressure, increase of pressure, both are correct, but temperature should be decrease. So here temperature is decreases, so option B is correct. Solubility of gas in liquid increase with increase in pressure, decrease in temperature. Got it. Then next, the Henry's law constant values of 3 gases A, B, C in water are 145. This is A KH value. Then 2 into 10 to the power of -3. B 35 is C. Respectively, the solubility of these gases in water follows the order. We know KH, that is solubility is inversely proportional to KH. Then KH which have less KH value that have more solubility. In this 3, B have less. Okay, then C, then A. So B is greater than C, C is greater than A. Got it? Here only is there. Next, KH value, again same type of question only. KH value they gave and gas they gave, and for that KH value they gave. Then they're asking a order. So which have more KH value that have less solubility. That's why they gave an answer this one. Got it? Then next one. At 298 Kelvin, the mole percentage of N2 gas in air is 80%. Water is in equilibrium with air at a pressure of 10 atm. What is the mole fraction of N2 in water? What we have to calculate? Mole fraction of water in N2. Sorry, N2 in water at 298 Kelvin. KH value they gave. Okay. Here what you will do? What and all they gave? Given is partial. The total pressure is 10. Then mole percentage they gave. Mole percentage of N2 is 80%. And KH value they gave. And remember, 1 atm is equal to 760 mm Hg pressure. Okay, now next, here what mole fraction of N2 I have to calculate. Mole fraction of N2 means we know mole percentage is equal to mole fraction into 100. We know mole percentage is 80. Mole fraction of N2 I have to calculate into 100. N2 I want means 80 by 100 if we'll do, we'll get a mole fraction of N2. Okay, now by taking that mole fraction of N2, we can calculate pressure of N2. Pressure of N2 is equal to mole fraction of N2 into total pressure. Then we'll get, if we'll multiply mole fraction into total pressure, you will get pressure of N2, that is 8 atm. This is in what they gave? In air. In air we have to take this formula. Got it? Then so because this one you will get to know in the later session. Vapor pressure allidaga vapor pressure of N2 is equal to vapor pressure of N2 by total vapor pressure. ಓಕೆನಾ, ಇದು ವೇಪರ್ ಫೇಸ್ ಅಲ್ಲಿ ಇದ್ದಾಗ ಮೋಲ್ ಫ್ರಾಕ್ಷನ್ ಆಫ್ N2 ಇನ್ ಗ್ಯಾಸ್ ಸ್ಟೇಟ್, ಇಟ್ ಇಸ್ ವೇಪರ್ ಫೇಸ್. ಅವಾಗ ಈ ಫಾರ್ಮುಲಾ ಬರ್ಕೊಳ್ಬೇಕು. ಈ ಫಾರ್ಮುಲಾ ಇಂದಾನೆ ನಾವು ಇಲ್ಲಿ ಇದು ಡಿರೈವ್ ಮಾಡಿರೋದು. ನೆಕ್ಸ್ಟ್ ನಮ್ಗೆ ಪ್ರೆಷರ್ ಆಫ್ N2 ಗೊತ್ತಾಯ್ತು, ಅದೆಷ್ಟು 8 atm. ಬಟ್ ವಿ ವಾಂಟ್ ಇನ್ mmHg because we have KH value in mmHg. That's why we are converting this atm into mmHg. I already told 1 atm is 760 mmHg. So 8 is 8 into 760. You will get 6080. Then if we'll calculate in water, mole fraction of N2 in water to calculate, you will use normal Henry's law formula. So what is that? P is equal to KH into chi. So ಇಲ್ಲಿ chi N2 is equal to, we want chi, right? That is mole fraction of N2 we want. So P by KH. P we got to know, KH they gave in the questions. Then we'll get to know the mole fraction of N2. ಓಕೆನಾ? ಸೊ ಏನೇನು ಮಾಡ್ತಿದ್ದೀವಿ ಇಲ್ಲಿ, ಫಸ್ಟ್ ಗಿವನ್ ಬರ್ಕೊಂಡು ಮೋಲ್ ಫ್ರಾಕ್ಷನ್ ಆಫ್ N2 ಇನ್ ಏರ್ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ಕೊಳ್ಳಿ. ಮೋಲ್ ಫ್ರಾಕ್ಷನ್ ಆಫ್ N2 ಇನ್ ಏರ್, ಓಕೆನಾ? ಇನ್ ವಾಟರ್ ಅಂತಂದ್ರೆ ಈ ಫಾರ್ಮುಲಾ ಬರಬೇಕು, ಇನ್ ಏರ್ ಅಂದ್ರೆ ಈ ಫಾರ್ಮುಲಾ ಬರಬೇಕು. Then this is JEE level. Consider a solution of CO2 gas dissolved in water in a closed container. Which one of the following plot correctly represents the variations of log, it is partial pressure of CO2 in vapor phase above water, it is in y-axis, with log mole fraction of CO2 in water, that is x-axis, at 225 degrees Celsius. ಅಂದ್ರೆ log P is equal to log mole fraction of CO2 and log KH. This is normal Henry's law only. So log P is y-axis, this is pressure. pressure of CO2 is Y, and this one is mole fraction of CO2 is x-axis, then log KH will be slope. So this slope you will get a straight line. So straight line ಎಲ್ಲಿದೆ ಇಲ್ಲಿ? This one. Henry's law ಅಲ್ವಾ? Henry's lawಗೆ ಇದೇ ತರನೇ ಬರುತ್ತೆ. Next they gave statement. Statement 1, the Henry's law constant KH is Henry's law constant KH is constant with respect to variations in solutions concentration over the range for which the solution is ideally dilute. For ideally dilute, KH value is constant. That is the main thing. Second statement, KH does not differ for same solute in different solvent. But I already gave 4 points in the end of that video. KH value will differ for same solute in different solvent. So statement 2 is false. Statement 1 is correct. I told you this one also. Ideal diluted solution, KH value will be constant. Okay. Statement 1 is true, but statement 2 is false. Okay, now. Then next, which of the following graph correctly represent the plot of KH at 1 bar for gases H2O versus temperature? Okay, so here what they are doing, they are plotting the graph, that is KH versus temperature. Here they give 3 gases. In these 3 gases, which one will represent? So here you have to remember, as temperature is increases, solubility will first decreases, then it will increase. As temperature increases, solubility first what it will happen? It will decrease. After some time, it will again increase. So Henry's law, what is Henry's law constant also? First it will increase, then it will decrease. At some point, it will decrease at moderate temperature. So we know KH value of He is more than Ni, then CH4. So this H2 is more KH value means it have less solubility. So here what is happening? Here increasing, again decreasing. Here increasing, again decreasing. In these two we are agreeing. But here in this two it is wrong. It is gradually increasing. It is also increasing. Okay, this two is cancelled out. Then in these two we know He have more than N2 then CH4. This KH means which have more? He have more value than N then CH. So this option B is correct here. Okay. Then next, for a solution of the gases A, B, C, D in water at 298 Kelvin, the values of KH are A is 30, B is 30.40, this is 30.40, B is 2.34, C is 1.56 10 to the power of minus 5 and D is 0.513 Kelvin bar respectively. In the given graph, the line marked P and S is corresponds to which? Okay, so here this P and this S will relate it to A or B or C or D. We have to see. So here we know pressure has maximum, P has maximum pressure. So this is pressure versus Ka. So which have more pressure? P have more pressure, S have less pressure. So pressure is directly proportional to, pressure is equal to KH, no? Yes or no? So maximum KH also it will contain. P will contain maximum KH because P partial pressure is more means KH also will be more. So P have more KH and S have less. It is minimum pressure, so minimum KH. So which have maximum KH value? Maximum KH value is for A, 30.40. So P is representing A. S have very less KH value. In this which have very less? C have very less. So S is representing C. So option A and C is correct. Got it? So all the PYQs from KCET level, NEET level and JEE level I completed in this video. Okay. For more videos, please do subscribe my channel, like and comment. Thank you.